Welcome to Chemistry Online. Today we're going to talk about the use of molarity in equilibrium expressions. We know from our ideal gas laws that PV is equal to nRT. We also know that the molar concentration of any gas is going to be directly proportional to the partial pressure of that gas. Now that's Avogadro's law. Now let's remember that the number of moles divided by the volume in liters gives us molarity. So if we write this, and remember that our volume here is given in liters, this is the same as molarity. So molarity is going to be the partial pressure divided by RT. Now let's do a simple problem here just based on concentrations. What we're going to do here is to solve for Kc. Now, Kc refers to an equilibrium constant based on molar concentrations. Some books will refer to a pressure-based equilibrium constant as Kp. Others just refer to it simply as K. All right, our equilibrium expression here. We're going to have the concentration of nitrogen, concentration of carbon dioxide squared, and that's our numerator. We're going to have the concentration of CO and NO, each of them squared, multiplied together, that's our denominator. All we have to do is substitute, do our simple solution. Our equilibrium constant is 0.196. Now let's do this a little bit differently here. Here I'm going to take some concentration data and I'm going to solve for a gas phase equilibrium constant. Now it's a simple reaction. Stoichiometry is 1-to-1. All we're going to do is write down our equilibrium expression and we're going to substitute and solve for our K. All right. Our gas phase equilibrium based on pressures would look like this. We remember, however, that we can take a partial pressure and we can simply substitute in molarity times RT for that pressure. For our numerator then, we could say the molarity of PCl3 times RT is the same as this pressure. Same thing for chlorine. We wind up with RT squared. In our denominator, we have the pressure due to PCl5, and it looks like this. Now we have two RTs in the numerator, one in the denominator. Those cancel. All we have to do is now plug in our values, plug in RT. We cancel these guys. Remember, molarity is the same as 1 over liters per mole, so those cancel. And we're left with 11.524 as our calculator answer. We have three significant figures. Our equilibrium constant is 11.5. This is our pressure-based equilibrium constant.